Given to you is your function defined on 0 comma 1, defined like this. Everything is known, everything is very good, except this square bracket which says that it is a greatest integer function, that is greatest integer that is less than or equal to that number. Okay, now they are asking about continuity of the function, derivability of the function, mean value, etc. What do you think? You want to know how your function is looking like without these square brackets, right? Then you will be able to explore that function more. So now let's try writing f of x without the square bracket. How do we do that? Okay, so where is my x first of all? Look at this domain. Your x lies between 0 and 1. Where is your 4x then? Your 4x would lie between 0 and 4. Now if you have square bracket around 4x, what do? You say that let us break into integer intervals. That means 4x lies between 0 and 1. Then 4x lies between 1 and 2. Then what's happening? 4x lies between 2 and 3. What's happening? And so on up to what? Up to 4, of course, right? Your 4x is going to lie between 3 and 4. Okay, now let's look at all these places and start writing my function. So what is my f of x? When you are here, that means where is your x then? Your x is lying between 0 and 1 by 4. How is your function looking like? What is greatest integer 4x then in this case? It's 0, right? So you say that overall it is 0, okay, because this guy is 0, everyone is 0. Now look at the second one. Where is your x in the second? 1 by 4 and 2 by 4, that's half. Okay, and what is the greatest integer for 4x value in this case? It would be this guy 1. Okay, and when this is 1, how is your function looking like? X minus half whole square, sorry, 1 by 4 whole square into x minus half. This is how your function is looking like. Next, this case, okay, that would mean that your x lies between half and 3 by 4. And how is the function looking like? Because in this case, your greatest integer 4x would be taking this 2 value. Okay, you understood that? So 2 times this into x minus half. Last one, let's complete this up. 3 by 4 and 1, this here. Your greatest integer 4x will take this value 3, and you are all done decoding the function. Now let's look at the continuity of the function. What do you think? Which points you would like to see continuity? Of course, these, right? The points where they are breaking. Okay, otherwise, anyways, these are polynomials, they are continuous. You have to only think about the point where they are breaking. That is 1 by 4, half, and 3 by 4. 0 and 1 is anyways not there. So you have to just check. Now, at x is equal to 1 by 4, let's check the continuity. What is your left hand limit at 1 by 4? Left hand limit means you are going to look at here. Left hand limit, you can clearly see it's 0, right? What is right hand limit? You have to look here, okay, because here right hand limit, you plug in x is 1 by 4, still you get a 0. Left hand limit is same as right hand limit, it's same as the function value. Okay, continuous. Okay, at 1 by 4 it is continuous, correct. Okay, now let's check at x is equal to half. What do you think at half? What is left hand limit at half? Again 0, right? Okay, 0. What is right hand limit at half? You are going to look here, plug in x is half, again 0. So that is right hand limit, and that is same as function value. Okay, it's the same 0. Function value at that point still continuous. Okay, check at x is equal to what? 3 by 4. I don't know what I can calculate, right? See, it's the same expression. This is multiplied by 2 and this multiplied by 3. At 3 by 4 you are going to get different values. Okay, so definitely LHL and RHL are not equal. We don't need not find out. So you have discontinuity, okay, at x is equal to 3 by 4. Okay, this first option, right? The function f is discontinuous exactly at one point. That's true. Function is discontinuous exactly at one point. Now let's check about derivability. Okay, so for derivability, what do you have to do? Find the derivative, of course. Okay, let's do that. Find the derivative f prime of x. Now same, okay, in all these intervals I need to find the derivative. Okay, so here, come here, it's 0 only, right? 0 when x lies between 0 and 1 by 4. What about the derivative of this guy? Can you try doing the product rule and finding the derivative? Okay, if you do so, you end up in getting the derivative to be x minus 1 by 4 and 3x minus 5 by 4. That's the derivative. Okay, product rule you know. And what's the interval? This. Similarly, you can see that the functions are same, just that this is multiplied by a 2 and this is multiplied by a 3. So derivative remains the same, just that you are going to multiply by a 2. Last one, 3 times x. Now let's start answering. What are they asking us? Which point again you are interested in? Again, the point they are breaking, right? 1 by 4, half, and 3 by 4. So at 1 by 4, what do you think? What is left hand derivative? This. Can you see that? Left hand derivative is 0. What's right hand derivative? You plug in 1 by 4, still you get a 0. So that is same as right hand derivative. So you have differentiability at x is 1 by 4. Okay. X is equal to half. What do you think? Half here, come here. At half you get some value, okay, which is of course not 0. Okay, and half here you get the same value but multiplied by a 2. That means definitely they are not equal, right? Left hand derivative is not equal to right hand derivative, not differentiable at half. Similarly, you can check at x is equal to 3 by 4. What do you think? Same thing, right? 3 by 4 you're going to get some value which is not 0, left hand derivative, and here also some derivative which is again multiplied by a 3 and not 0. Okay, so they can't be equal, so left hand derivative is not equal to right hand derivative. Okay, now let's start answering. There is exactly one point in 0 1 which at which function is continuous but not differentiable, of course, right? At half you said it is continuous but you said it is not differentiable. Okay, so this is correct. Answer the C part. The function f is not differentiable at more than 3 points. We just now got, right? Only 2 points where it is not differentiable. So this is wrong. Okay, now to answer the minimum value of the function, how do you answer that question? Remember the critical points and when your function is increasing, that means when is your derivative changing sign. Okay, let's look at that. What are the critical points? Derivative is 0. Okay, can you check? 1 by 4, you can clearly see from here, right? That everyone has this expression x minus 1 by 4 and 3x minus 5 by 4, except the first one. Okay, so you have this interval 0 and 1. Till 1 by 4 you are 0, derivative is 0, that means your function is a constant function. Okay, now from 1 by 4 to 1 you have the same expression, just that you are multiplying by a 2 and then by a 3. Okay, now what is sign about this function? Can you write the sign? Because this is 1 by 4 and this is 0 at 5 by 12. Okay, that means at x is equal to 1 by 4 and 5 by 12 they are going to change signs. 5 by 12 is where? Zero point 0.4 something. Okay, so 5 by 12 is somewhere here. Now look at sign of this function, this function. If you are more than 1 by 4 and 5 by 12, that means this whole thing is positive. That means derivative is positive, your function is increasing. That means you are increasing here. Okay, that means this is negative and this is positive. Okay, before 1 by 4. That means you are decreasing here. And before that anyways you are constant. That means at 5 by 12 your function is attaining the min value. Okay, now you get what is f of x at 5 by 12. Okay, how does your function looks like at in this interval, like 1 by 4 and half? 1 by 4 and half, it looks like this. Okay, so you just get this function and plug in 5 by 12. So you have x minus 1 by 4 whole square into x minus half. You are going to plug in 5 over 12. And how much do you get? Let's check. 1 over 4 whole square and 5 over 12 minus half. Okay, and how much do you end up in getting? This would be this over 12 whole square, and this would be how much? Minus 1 over 12. Okay, and this will lead you minus 1 upon 432. Okay, so the min value of the function is minus 1 upon 432, so this will be a wrong option. Okay, so I will see you with another question soon. Bye bye.